As you saying, I'm just going to do a quick overview. It won't take that long. Talk to you a little bit about Aeroflex. We're actually we're a corporation located out of Plainview, New York. There's two divisions. There's sides of the company. One is Micro Solutions, and the other one is Test. And we're out of the Microelectronic Solutions area, AMS. We've been in business since 1937, sort of growing through acquisition. We're buying, we've been buying companies that help fit well with our organization and growing by that way and adding more and more capability to our to offer our customers. In the test side, they're mainly focusing on radios, land-based type of things, radios and test equipments to test those radio systems and broadband communication and things like that. And on our side, we're really supporting the space and aerospace companies. So this is a little bit more on each side of the thing of our corporation. So on the, I hit the wrong button there. So on the AMS side, we're going to have high rail parts for space. We're fabless semiconductor providers. So while we do our own designs and everything, we go to various fabs out there, which best fits what we're trying to build to get them fabricated, and then we do all the testing and integration ourselves. We're designing into hundreds of different platforms and helping companies be successful in their missions. As you can see, we have a broad base of products to offer our customers. When I first started in 1995, we had probably 8 different products, standard products, and some ASICs. And since then, we have grown into everything from system type of level things where battery electronic units to help monitor lithium-ion batteries to down to diodes that we can offer customers. So next couple of slides, we're going to talk a little bit more about individual offerings and divisions. And out of Hopkins, we have a motors division, and they specialize in motors that can be flown in space. They were part of the original Mars rovers. They were, when the ball hit the ground and was bouncing along on the surface, they had those fins that came out and uprighted it. They drove the motors that would actually open up the balloon, I guess, after it landed, and allowed it to upright and make sure the rover was level when it drove off. And in the current Curiosity, we have all the actuators and motors on the wheels, all these motors here. That is a motor that drives the lens focusing mechanism on the camera. They have, I think, like 19 different motors on the Curiosity. So they're doing quite well there and supporting NASA in a lot of different opportunities. We also have a slip ring company but that's mainly for terrestrial type of applications, even though they are developing a space qualified slip ring currently. And they also, out of our hog pod, we have gimbals. Out of our Aeroflex Plainview division, they do a lot of chip on board and hybrid type of assemblies there. They also have some standard products, but they do a lot of custom work where they do DC-DC converters with chip on board and planar magnetics built into it. They can do RF type of modules, high power to RF type of modules. You see here and here. And then out of Colorado Springs, we do some evaluation boards, and also out of our Geisler division, we have some evaluation boards, which I'll talk about later. And we also have some space wire boards. So whether there's something custom a customer need, and we'll help support them there, or we're doing some on our own boards to help support our standard products, we're doing all kinds of different development in this area. We also have the chips that you guys use here at Southwest Research and other companies like Johns Hopkins use in their missions, from processors to memories to logic type of devices to RF devices. So we have again hybrids where we can do motor controllers and high power custom MOSFET type of applications too. And we're starting to get in more and more into the passives, from high voltage MOSFETs to diodes and transistors. You can see here. But why are we here at this particular conference supporting this this software meeting? Well, it's because several years ago we acquired a company called Geissler. Now it's Geissler Aeroflex. They have all kinds of IP that could be used in FPGAs and ASICs, and we started using that to develop our own 32-bit processor. And this is our first offering to the space community, the UT699. And we've got all the peripherals to help support that, from memories to non-volatile memories to logic to FPGAs. So in order to support a 32-bit processor, you need some tools. I'll talk about those in a few slides, but while the UT699 is available, we do have a roadmap to bigger and faster devices. Han was talking about a couple yesterday coming out of Geissler, and that's mentioned here. But we also have some coming out of Colorado Springs. We have the UT699, which is available now. We have the UT699E, which is going to be a migrated version. This is built on a 1/4 micron process. This will be a 130 nanometer process, so it's going to be faster. It'll be less power. It's also going to have a few enhancements, but overall it'll be a drop-in replacement for this one if people need that extra speed. We have the GR712, which is available now, and that comes out of Geissler. And we're taping out on the UT700. Well, it's actually already taped out. We'll get more die, have die available early next year, and prototypes mid next year for the UT700. UT700 adds a few more features like 1553, more space wire ports, SPI interface, things like that. And we are currently developing a quad-core Leon 4 FT. So that's in process and design at this time. So we do definitely have a roadmap to support customers in the future with lower speed products like the UT699 to very high speed processors in the future. So this is what we have to offer customers now, and what we're developing. So we got the Leon 3 FTs available, the GR712 is available, and using the Geissler IP, you could do more of a custom scaled down version of a Leon in an Actel or a Xilinx FPGA, or any FPGA for that matter, depending on what you want to use it for. And next year we'll have 2 more. The Leon, the UT699E and the 700. And in several years, probably 3 years after that, 2 to 3 years after that, we'll have our quad cores available. So this is why we're here today and talking to you guys and have a booth out there and trying to help these answering questions you may have. Is because to support those processors, we got to have debugging tools. We have to have simulators, and we have to have some hardware. And we have those tools. GRMon is a really nice debugging tool. You can see you can do trace buffers, breakpoints, watch points. You can look at your memories. You can look at cache. You can look at the registers that the Leon's using to process the instructions. So other than, as a customer pointed out yesterday, other than if there's a conflict going into memory, it runs autonomously in the background. So it doesn't, shouldn't, for 99% of the time, shouldn't slow any of the things that you're actually processing in your program down. We support several different operating systems, which I'll have on the next slide. We actually have our hardware set up at the booth, and we're going to be running some demos. So if you want to stop by and see a quad core running and looking at a quad core, I believe what he's going to be demoing is a quad core with 2 different operating systems going on simultaneously. So you can check that out. The T-Sim is actually a very valuable tool. If you don't want to spend the money to buy an evaluation board or have hardware or have a lab you have to go to actually start writing and testing your code, you can buy one of these T-Sim modules and actually just plug it into your computer at your desk, and it will emulate the UT699 and all these other these software peripheral ports that you see here. So it's a quick way and an easy way to get up and running without having to have hardware. These are the operating systems that we do support at this time, and the peripherals. You see here the peripherals, if they're in green, they are supported with that particular operating system, how much memory you need to support them, the platforms you would need, and whether there's a fee for them or not. Okay, so along with that TSIM module, we have other ways to evaluate your and develop your systems. So we'll have you, as these new processors come out, we'll definitely be developing evaluation boards, and all the ones that we have out available now, like the UT699 and the GR712 and even an advanced version of the next generation multiprocessor, we have evaluation boards that you can get and start writing code for. And if you have a Xilinx board or an Altera board sitting around and you would want to play with a Leon, they can help you with a configuration for whatever evaluation board you may have laying around, and start using a Leon type of image, and you can just start writing your program with it. They also have a RTOS system with our boards that are available, and Xilinx and FPGA-based boards that will go in there. So that's really all. Just wanted to give you a brief overview. If you have any questions, feel free to ask them now or stop by the booth outside, and we're happy to try to help you.